Okay, so the next topic is electric dipole. What is electric dipole? Say, an electric dipole, what is that? It is nothing but a pair of equal and opposite charges which are separated by some small distance. So that is what is called an electric dipole. What is an electric dipole? It is the pair of equal and opposite point charges separated by a small distance. Okay, therefore this is a charge minus q, point charge, and this is plus q. Okay, and this the distance of separation between these two, let it be 2a. Let it be 2a. Therefore, this is what is called an electric dipole. It is a combination of, what is that? Equal and opposite charges. Equal and opposite charges. Here minus q and plus q, and they are separated by a small distance. So this is what is called an electric dipole. Electric dipole. Are you following? Therefore, see, if this is you can say what is the center of the dipole? Here the line joining, center of the line joining the two charges. Okay, that is what is called center of the dipole, that is O here, right? So but you cannot say, see here equal and opposite charges are there. The total charge of a dipole, what is that? Therefore you can say total charge of the electric dipole. What is the total charge? Plus q minus q, therefore that is equal to 0. Okay, but very important thing is, it doesn't mean that, okay, the electric field due to a dipole is also equal to 0. You cannot say that electric field, it doesn't have any electric field. Total charge is 0, but you cannot conclude that. It doesn't mean that the electric field due to a dipole is also equal to 0. It has a what is an electric dipole has a very strong electric field around it. Okay, that we will be seeing later, right? Now, for example, if you see atoms or molecules of ammonia, water, alcohol, okay, therefore ammonia, water, carbon dioxide, and HCl, etc. Therefore, all are some examples of electric dipole. So, how do you say atom or molecule as such? It is neutral in nature, but how do you say it here? Positive, negative charge here. It is center of mass. Here, what do you mean by that? They are an example of electric dipole. Why? How can you say? Because in these cases, okay, in these molecules, the center of mass of positive charge and the negative charge. Center of mass, there will be, there are, say for n number of positive charge, then n number of negative charge will be there. Center of mass of all the positive and the negative charges are separated by a very small distance here. Therefore, hence you can say that they are, what is the electric dipoles. Are you following? Right. Now, see, therefore, what is the strength of the electric dipole? How to find out the strength of the electric dipole? See, the strength of the electric dipole is given by a quantity, it is expressed by a quantity what is called dipole moment. Dipole moment. How to represent small p? Dipole moment. Okay, so strength of the electric dipole is given by what is its dipole moment. Okay, so it is the measure, dipole moment is a measure of the strength of the electric dipole. Okay, so What is it? Electric dipole. Actually, it is a vector quantity. That is why I have written here P, a vector quantity. So, vector, what is it? It is nothing but the product of, okay, product of the magnitude of the magnitude of either charge, plus q minus q, therefore either charge and, okay, the distance between them. It is a product of, okay, therefore what is it? It is a product of the magnitude of either charge and the distance between them. Okay, therefore you can say P, that is equal to Q into 2A. Q into 2A. Then therefore P, but it is a vector quantity. It is a vector. P is a vector. Therefore vector means it should have direction now. Therefore P, the dipole moment P, the direction is, okay, direction is from negative charge to positive charge. Negative charge to positive. Therefore, how to represent here? Come back to here. What is P here? P should be, what is P? P should be from negative to positive. This is the direction of P. Okay. Therefore, now what is the unit for dipole moment? Unit of P. What is that? It is nothing but P, you know that is equal to, magnitude of P is nothing but Q into 2A. Therefore, what is the unit? It is coulomb meter. Unit is coulomb meter. Okay, therefore what is dimensional formula? Dimensional formula for P of dipole moment. That is, tell me, coulomb meter. Therefore coulomb is A T and meter L. Okay. So this is A power 1, T power 1, L power 1, M power 0, of course. Is it clear? Right. Therefore, if that, see, now I want, what is called, I want to give you what is ideal dipole. Ideal dipole means, what is that? Is the smallest dipole, okay, having almost no size. Ideal dipole means, what is it? It is the smallest possible dipole actually having almost, what is a, no size. Okay. Therefore, when you will get, see, if Q is, P, that is equal to Q into 2A, smallest dipole, but what is that here? It is, that is also called point dipole. Okay, ideal dipole, or it is also called point dipole. Point size dipole means, what is that? Q becomes very large, but the distance of separation 2A gets smaller and smaller. Q gets larger and larger, and 2A gets smaller and smaller. Therefore, what is that? You will get a dipole with almost a very small size, point dipole. Okay. So, this is what is called a what is that? Point dipole. Okay. Here charges are very, what is that? Very large charges, but the separation, positive and negative charges are very large. Okay, but the separation between them is very small. Then you will get an ideal dipole. Are you following? Right. We will see one problem now. Very simple. There is a, what is that? Charges. Now, numerical is, see, charges plus or minus 20 nanocoulomb are separated by 5 millimeter. Calculate the magnitude and direction of dipole moment. Okay, so what is that? Here charge is given by 20 nanocoulomb. You are asked to find out the magnitude and direction. Okay, see what is the magnitude here? P, that is equal to Q into 2A, right? Therefore, what is Q here? 20 nanocoulomb, 20 into 10 power minus 9. And 2A is the distance of separation. It's not 2A is the distance of separation between the two charges. Therefore, it is 5 millimeter now. Therefore, it is into 5 into 10 power minus 3. Okay. Therefore, you will be getting, yeah, what is that? 20 into 5. Therefore, it is 10 power minus 10 coulomb meter. It is coulomb meter. So, this is the magnitude direction. What is the direction? Direction from negative charge to positive charge. Correct? It is from minus 20 Newton per nanocoulomb to plus 20 nanocoulomb. That is the direction. Is it clear? So, the next class we will see the field, the electric field intensity due to the electric dipole. Is it clear?